Now, let's look at a question where we have to apply the Newton's law, but we have to look for uh, limiting case, right? So let's look at the question. A mass of 2 kg rests on a rough horizontal table. So this is 2 kg mass, right? The coefficient of static friction between the block and the table is 0.6, right? So this is the mu static. The block is attached to a hanging mass by a string that goes over a smooth pulley. And this is our hanging mass M. Determine the largest mass M that can hang in this way without forcing the block to slide, right? So the condition we have to look for, why will the block will start to slide, and what is that, right? The only reason why this block could start sliding is that some force is acting on it. And in this case, there are possibly two forces. Number one is the tension, which is going to pull it, right? And if there's no friction, automatically it will start moving towards right. But there must be some friction force here, which is acting, which is trying to prevent the block from sliding. Okay. Now, as we know, there's a maximum value of the static friction force, right? And we have to find that maximum value and see that is equal to the P, right? For the M, we have to draw the free body diagram in the same tension because the string is same, and it will have mg pulling it downward, right? So when just start to slide, that point of time in this body number 2, my P is going to be equal to mg, and here for it to start sliding, P has to be equal to or greater than Fx max, which gives us F static max, right? Just to start to slide should be equal to T, which is equal to mg. So my M, which is the maximum value of the mass which can sustain, is going to be Fx max divided by g. Okay, so let's find out what is the Fx max value. Fx max, we can find what is the static friction force. Is simply the coefficient of static friction multiplied by the normal reaction. Okay, so this is the normal reaction, and this is my mg, which is 2 into 10, which is going to be 20 newtons, right? So we are taking g is equal to 10 meter per second square. Okay, so my Fx max here is going to be mu s. Mu is 0.6 into normal reaction in this vertical direction, n is equal to 20 now, right? It's going to be 20, and that is divided by the g, which is going to be 10. We can cut this, we will get 2, and that is going to be 1.2 kilogram. Okay, mass is 1.2 kilogram. So if we have a mass which is up to 1.2 kilogram, there will not be any sliding. If we have anything more than that, we will be producing more tension than the static friction force can support, and the box will start to slide. So our correct answer is 1.2 kilograms.